received your email, and thank you for sending those sample images. What I would suggest is using FIJI, which is an open source imaging software that's available online through an NIH website. And FIJI is essentially ImageJ, but with a full suite of tools that that are very useful with this software. So you download FIJI if you don't have it. It doesn't. It supports Windows. It's also available for Macs as well as Unix. So once you have FIJI, just install it and load up your image. So you can drag or drop, or you can just simply open and locate the file where it's located. So here's the image. From the standpoint of image analysis, it's best if you think about it in simple terms. And what we're going to do here is do a very simple particle counting. We're interested in counting the dab positive, or rather the dab color or brown color objects in this image. And so once you load the image, the first thing to do is we want to instruct the software as to what we want it to count. So for that, we go to image, adjust, color threshold. So once the color threshold shows up, now what we're going to do is isolate the color that we're interested in for the particles to be counted. So as you can see here, you can, when you move the, and I would suggest taking dark background off. Just makes it a little easier to see things. So here, for instance, we can start with brightness, so things that are strongly stained, as well as saturation. You can dial saturation however you think it's representative of what you're interested in. For color, I find that somewhere here in the middle, and again, you can use the sliders. You can also zoom into this image to see what you're actually picking up. And if you feel like you need to pick up a little more, then you can work the sliders in the direction that you feel is best suited for the analysis. So I'm going to zoom back out here to the whole image. Looks like there's some noise down here, so again, we can try to eliminate that. So that kind of helps it. And so once you've selected what you want counted, you hit the select button. So select, and it throws a mask on top of the items that you have selected based on the hue, the saturation, the brightness. All right, so now once you have done this part, you want to then isolate that mask. And then the way to do that is to go to binary under process, so process, binary, make binary. And so here, what you've selected is brought forth, and everything else drops away. And that's good, that's what you want. The next thing is ideally you really want a bit more spacing between objects, so whether it's higher magnification or maybe not as strong of a stain, that's usually ideal for counting. But one of the things I do like to do is under binary is to use the watershed function, which basically what it does, it breaks up clusters. It's not perfect, but at least for a blob of something that you have here, you can have the software attempt to find gaps so that it can break up clusters. All right, so then for the next step is we want to set the measurements. Here, just area is fine. You don't really need anything else for this purpose. You can also, and then analyze particles is here. Now you can calibrate image J if you have a micrometer and take some pictures with the same setup that these pictures were taken. You can, for the slide scanner, the same thing. You can have, you can scan, or you can get the pixel size information from that, from the Apereo instrument, and you can calibrate image J. But this is in pixels. So I know that if I measure what I think it's a representative cell staying positive with DAB, then it's roughly around 10 pixels or so. So what I'm going to do here is limit for size, and this is pixel square. I'm just going to go from 0 to 10, or I mean that's, you know, it's rather large, but that's okay. I mean we can go a little smaller. We do want it to show what it actually counted, so outlines, and we want the software to display the results. Now circularity is also a good one to use for immune cells, since they're more circular. So you can eliminate things that are not as circular. So you can go, say, 0.5. The closer to 1, the more perfectly circular it is. So we can eliminate things that are not as round. This range also will bring in elliptical shapes and so on. So let's see what happens. We hit OK, and there's a bunch of numbers here. So from the total count, looks like 5,667 is my total count based on that criteria. And again, you know, these are, you can always fine-tune this in different ways based on the parameters that I showed you earlier. You can also zoom in on this and see what number corresponds to what particle. And that's basically it. Again, here are the results. And you can also create a macro in which you set up the parameters that best fit the analysis, and then you don't have to go through all the steps on the next go. You can just load up the image and load up the macro here, load it up and run it. So that's something that really cuts down on time. All right. Hope this helps.